All right, here we go. Welcome to lesson 4.3 on rotations. We're working our way through chapter 4. Um, Next transformation up is rotations. So if you're going in sequence, we did translations first. Then we did reflections in lesson 4.2. Rotations is next. Let's do it. Let's get in. Let's get this done. First thing. So I feel like I don't know why I don't have it here. I'm actually going to slide this just a smidge down and define rotation. We did that for all the other ones. I'm not sure why I don't have it here in my notes. So this is what we did in class. Rotation. What is it? It's a transformation. So let's say that a transformation that let's say turns. I kind of like that. I can see below here it says something about turning, that turns a figure. And I'm going to use this word about. It kind of just means around. Turns a figure about a given point. Okay. So that's, again, just trying to stay consistent with the notes we've been doing. That's how we would have done it in class. The rotation, it's a transformation that turns a figure about a given point. Um, it literally rotates the figure. And then the only thing I think we said was that given point is called a center of rotation. So I think we just wrote center of rotation down and just kind of said that's the name of the point that we're rotating about. And we didn't do even a whole lot with angle of rotation. We mentioned it, but we didn't write anything down about this. Because we're going to work with very specific, if on the intro there, if you saw it, we're specifically working with 90 degree, 180 degree, and 270 degree rotations. Okay. But if you're looking for what is, that angle of rotation, it's if we start, with what they're saying is a ray. So here's my ray from my original picture from P to Q. I drew a ray, and then from P to Q prime on my new picture, right? I've got two separate rays, or even segments in this case, and we got a protractor out and we measured, hey, what is this measure? What is this angle right here? That's where that 40 degrees is coming from. Okay. Again, we didn't, other than just talking about it, we didn't add that part to our notes. All right. So what did we add? Basically, here's what we need. So right in this section, right in rotation, center of rotation was mentioned. Let's just put rules. Okay. I guess before that, it can be in the rules section, I guess. For rules, coordinate rules, we just said rules for rotations. We did say, though, we will only rotate about the origin. Okay. So these rules are specifically for rotating around the origin, where this given point, we will only use 0, 0. Okay. So that's kind of nice. It's limited. We're just doing a very introductory look at rotations. So our rules are set up to go about the origin, around the origin, and we also noted that our rotations are going to be counterclockwise. Okay, so moving this way around our coordinate plane. Okay, so big things there. Rules for rotating about the origin, and then we kind of put just like a comma, counterclockwise, or counterclockwise about the origin, you could say. Okay, but then we added these rules, like they look very similar, right, to our reflection rules, right, where it says take the point AB. If you want to do a 90 degree rotation, take the point AB and turn it into the point opposite of BA, and then so on. For 180, it's a different rule. For 270, it's a different rule. Okay, so that's it. I mean, add those to your notes, and then basically we practiced them. We did one of these two examples. I'll do them both here in the video for anybody watching at home or in study hall. Let's take a look. Okay, so it says graph the quadrilateral KLMN with these vertices and its image after a rotation of 270 degrees about the origin. Okay, so that fits exactly with what we're doing here. 270 degrees about the origin, counterclockwise. Okay, if it doesn't specifically say, it's implied that we're rotating counterclockwise. Okay, so let's do it. Let's get this done. First thing we can do is plot our original 1, 2, 3, 2. 1, 2, 3, 4, 2. 4, 1, 2, 3, and 1, 2, negative 1 here. So there's my original, kind of a weird looking little quadrilateral. Sometimes I like to leave, especially with rotations. Although I guess I'll do it here. It doesn't. I was going to say sometimes I leave the labels off: K, L, M, and N, just because I feel like a lot of times these ones, it's hard for me to visualize where this is going to be after we rotate it. Like it's going to start here. It's going to go 270 degrees about the origin. It's going to end up down here somewhere, like in this vicinity, but I don't know exactly where. It's hard to kind of visualize. So sometimes, I guess, long story short here, I don't like when my new image overlaps with all the letters on this one. So sometimes I say I'll wait and put them on at the end, but then I also feel like I forget to do it. So whatever, there they are, KLMN. All right, my originals graph. Again, just set up stuff. Make sure you're taking care of the little detail stuff. We should be putting arrows here to indicate a transformation is taking place on all 4 of these points. I'm going to label my new points in the box. This is my annotation, my documentation of what's going on. So this is kind of just all setup stuff. I'm trying to be efficient with how I do it. And then, all right, now it's time to actually do the rotation. So where do I look? I go back to my notes here, or on a quiz or a test, you'll get a little sheet of paper that has these rules. They're not things you have to memorize, but I want to make sure I grab the correct one. For 270, it says take the point AB and turn it into B, opposite of A. So I actually like to write that down right here, kind of underneath where I'm doing my work. Take the point AB and turn it into the point B, opposite of A. All right, just so I have it, just so I know, I don't forget it. I'm not going back and forth looking at a sheet of paper or whatever. Okay, here we go. The interpretation here is, this is how I usually do it. AB becomes B, kind of opposite of A. So that means take this B, the Y coordinates, right here, all these Y coordinates, and kick them up to the front. Make them the new X coordinate, but don't mess with their signs. Just kick them forward. So that's what I usually do. I do that all at once. I'll bring this 2. I'll bring this 2 up. I'll bring the next one, bring this 2 forward. I'll bring this -3 forward. And then I'll bring that -1 down here. I'll bring that forward as my new X coordinates. And then as I kick my original A's, right, my X coordinates, as I kick these first numbers to the back, I need to make sure I change their sign. Okay, so this 3 gets kicked to the back and it becomes -3. That 4 gets kicked to the back and becomes -4. Okay. 4 gets kicked to the back, becomes -4, and then same thing with that 2 gets kicked to the back, becomes -2. So that's how you use the rules. And I know we talked about that in the previous lesson. That's it. Like, so the box part is done. I've got all my arrows, my notation, correct coordinates. The last thing to do would be to plot it. So let's get that done. Where are we at? 1, 2, -1, 2, 3. Okay, so that's why I'm glad I left that N up on top there. Again, not a huge deal, just so I'm not over the top of it. So that's my new K prime. L prime is going to be 1, 2, 1, 2, 3, 4 down here. M is going to be -1, 2, 3, 1, 2, 3, 4 down here. And then last but not least, 2, no, I'm sorry, I'm looking at the wrong spot. -1, -2 ends up being right there for my N prime. So if I label everything here, N prime, M prime, and then this was K prime and L prime. Give them the old connect the dots treatment. That's where we end up. Not as like visually pleasing. It doesn't have that symmetry quality that we saw with all the reflections. But basically, if you can picture it, this pink triangle, the original, the pre-image, got picked up basically and spun around the origin, around 0, 0. This part always kind of stayed facing the inside. All right, so it's kind of picking up, it's swinging, it's swinging, it's swinging, 270 degrees. We ended up down here. So 3/4 of the way around. If we were to keep going, it should end up basically right back on top of itself for 360. So it loses that visual check a little bit, but I know we're good here. We're in the right spot. We follow the rule. Let's do one more. Why not? We're here. If you're feeling good, obviously you can kind of jump ahead. Let's take a look at example 2. Not much different going on here. It's a trapezoid. This one specifically says trapezoid DEFG has vertices. Here they are. Graph the original DEFG and its image. That just means that's saying we should have both graphs after a 180-degree rotation of DEFG about the origin. Okay, a lot of that's just kind of stock phrase. We're going to say about the origin on every single one of our rotations. Here we go. Let's do it. Where does this one end up? Let's go. Let's put the original on -1. 1, 2, 3 is right here. 1, 1, 2, 3 is right here. 1, 2, 1 is right there. And then 1, 0 is right there. So again, kind of small little trapezoid here. Let's see. D, I'm going to put up here. E, F, and G. Just some double check. I feel like I was screwing something up there. Okay, everything's graphed. The original, our pre-image. Let's get our, what would look good with this blue here? Let's go blue and red. I'm going to get all set up. D prime, E prime, F prime, and then G prime. I'll get all my parentheses rolling here. I just need a different rule, right? So I'm going to go back to my rules. I'm going to look at the 180-degree rotation. Says take the point AB, turn it into opposite of A, opposite of B. I kind of like this one. I feel like it's probably the easiest of the 3 to do. It's basically saying just switch the signs on everything. On all your coordinates, make all the X's their opposite sign, make all the Y's their opposite sign. It doesn't mean make everything negative. It just means switch the signs. That's why I'm trying to say opposite of A instead of -A and -B. All right, so let's take a look. Let's do it. I'm still going to write it out just to stay consistent with how I'm doing all this stuff. Take AB and turn it into the point opposite of A, opposite of B. All right, here we go. So I'm looking at all these X coordinates. I see -1, make a positive. I see +1, make a negative. I see +2, make a negative. And I see +1, make a negative. Same thing with the Y's. Take this 3, make it negative. Take this 3, make it negative. Take that 1, make it negative. Now with the 0, obviously it doesn't have a sign, so that just can stay as is. Like there's no positive or negative 0, so that's one that's not gonna change. Again, fairly simple with the rotation there. Here we go. We can plot those and be done. 1, -1, 2, 3 is down here. -1, -3 is going to be over here. -2, -1, and then -1, 0. So we get them all connected up. I label everything out. This is D prime. Where did we go next? E prime, F prime, and G prime. This one I like though, like just visually, you can see, I think that was a 180-degree rotation. Usually those ones are a little bit more easy. It's got more kind of that, you can tell it was rotated 180 degrees about the origin. So yeah, not much more to say or do with that one. Okay. Let's keep it moving. We're doing great here, time-wise. The only other thing we would do with a rotation would be to look at doing it a different way using matrices. So again, super similar to the reflection notes. We wrote basically in class, we said we can do a rotation with matrices. We didn't add this necessarily, that it's still just rotating about the origin. And we really just kind of said it's the same as the previous lesson, that we multiply this. This gets written in front of your pre-image, the correct matrix, the appropriate matrix. You multiply it by the pre-image, and then you end up with the image matrix. Okay, so pause it here. Get the 90, 180, 270. We didn't do the 360. I don't think I'm going to ask you to do anything with the 360 because you can't tell anything happened, because when you rotate something 360 degrees, it just ends up on top of itself. So we just added these 3, 90, 180, 270 to our notes, and then we did the example together. All right, so here we go. Again, a lot of the language here is the same as the previous lesson. Let's do it. Let's get it set up. Okay, so triangle ABC. I'm jumping ahead a little bit, and I'm gonna look at, the first thing I want to look at is what kind of rotation are we doing? All right, so it says 90 degrees about the origin. I'm going to go pick up the appropriate 90-degree rotation matrix, which is 0, 1, and -1, 0. Okay. I'm going to take the coordinates of our triangle that are listed up here. I'm going to write them in a pre-image matrix. I'm going to try to leave a little bit of room for my labels at the top. We're still labeling everything. I know there's no box here, but this is my documentation portion of what we're doing. The A, B, and C should all get listed here like this. And we know from previous lessons that these get listed vertically. So the A has the coordinates -2, -2 written like this. B has the coordinates -3, +2. And then C has the coordinates 1, 4. All right. I may as well, while I'm here, set up my A prime, B prime, C prime image matrix. Let's see, what else can we do beforehand? We can get this the pre-image plotted. So -2, -2 would be here. -3, +2 is up here. And then 1, 1, 2, 3, 4 is over here. I think we're good to kind of put that one on there and label everything. A, B, and C. All right. Now, again, we can kind of, I don't necessarily have to see all of your multiplication. We can kind of fudge this a little bit. But I still do usually, me just personally, like to at least do the first round of multiplication to kind of see what's happening. I want to double check that I don't screw it up. And so here's what we're going to do. I'll show you what I mean. I'm going to take this top row still. That's how multiplication works. I'm going to turn it upright. So the 0 goes on top, the -1's on the bottom, and now I'm lining it up with this first column. Okay? I'm lining it up with that -2 and the -2 on the bottom. I do the multiplication, I get 0, I get +2 right here. I add those together. 0 plus 2 is +2. That's my first new element in my table. We can do another one, okay, just to kind of make sure we're still on board with the matrix multiplication. Now I'm going to slide that 0 and 1 over, and I'm going to multiply it right here times that -3 and times that 2. I'm going to get a 0, and I'm going to get a -2. I add those together to get -2. That's my next element. Now what's happening here? Essentially, we're picking up, you can kind of see that 0 kind of basically kills that top row, like this 0 times -2 was gone, 0 times -3 was gone. And then the -1 on the bottom is multiplying these lower numbers by -1. And then ultimately what happens? They get brought up to the top. Okay, so by the third time, I'm feeling pretty confident that, all right, I took this -2, I brought it up, it became positive. I took this 2 down here, I brought it up, I made it negative. This 4 is going to be multiplied by -1. We're going to add it to 0, and it's going to come up top as -4. Okay, so that's what I mean. You can kind of fudge it a little bit and not necessarily have to do every single multiplication because it can be tedious. I get that, especially if you really understand kind of what's happening with the rules, basically. Like for a 90-degree rotation, the y coordinates come up front, and the signs change on them, basically. Let's do one round on the with this lower row, so that 1 and that 0 get turned up. I'm coming back here. I'm going to multiply it by that -2 and that -2. I multiply together -2 and 0. Similar, but not exactly the same, right? I add those together. I get -2. Now what's happening here? Now maybe you can't tell just because, like, what happened? Is it this -2? Is it this -2? What's going on here? So you might want to do another round of it. I'll do one more. I feel like I got kind of turned around there and I don't know exactly what's happening. I'm going to slide it over, and now I'm going to multiply this -3, and I'm going to multiply that 2. I'm going to get -3. I'm going to get 0. I'm going to add them together to get -3. Now I think I can figure out what's going on. All right, this -2 got brought down to the bottom. This -3 got brought down to the bottom. What's going to happen to this 1? It's going to get brought down to the bottom exactly as it is. Okay. So a little bit of work. We got there though with our matrix multiplication. I feel like documentation and annotation wise, everything's great here. We got the rotation matrix, the pre-image matrix, the image matrix, all labeled correctly with prime notation. And then the last part would be just to graph it, right? So put this image matrix, turn it into back to ordered pairs, and put it on the graph. So where are we at? We're at 2, -2. We're at -2, 1, 2. Whoops. And then 1, 2, 3. Oh, right on top of that A, right? And then -4, 1, 2, 3, 4, +1. Here is my new image. And this was A prime. This was B prime. And this was C prime. Okay. Hey, look, I guess, I can't really tell perfectly, but I feel like that's a rotation of 90 degrees. I can live with what we have there. So that's an example of using matrices to do a rotation. Okay. We're close. We're almost done. I got one more example here for us. It's not another matrix one. I feel like that's good enough with what we've been doing over the past couple lessons. But the one thing that shows up in this lesson for the first time is right here. We added this to our notes. It was just a short little section. It's definitely after rotations. This is more broad for all transformations. So kind of section off the notes and just say kind of like a separate section on compositions. That can be your heading there. We wrote basically what it was. So we started kind of here. A composite. We just said a composition. We started right here. A transformation that is a combination. I know it kind of sounds like composition. A combination of two or more transformations, kind of done on the same pre-image. But I think that's fine. Just a combination of two or more transformation performed on the same figure. The tricky part is this, though. We did say perform in the order listed, so you always just go, like, here's an example of one. Maybe it's helpful to see one. It says, this is the example we're going to do. It says do a reflection, then a rotation. You go in order. You do the reflection first, then the rotation second. But you also, you keep working off the new figures. All right, so like on this one, for example, we're going to do the reflection. We're going to come up with a new set of points right here. And then when I go to do the rotation, I'm not going to go back to the very original and rotate it. I'm going to work off of this middle one and say, all right, now that we've reflected it, let's rotate those points about the origin. Okay, so hopefully that makes sense. You never go back to the beginning. You always keep working off of what you have. Okay, so we kind of said something about that, like performed in the order listed. Do the first transformation, and then your second one is performed on that new image, on that second image that you just came up with. Okay, let's do one. I think it'll make sense here just by going through the process of doing it, and then that'll be that lesson over. So here we go. Graph segment RS with endpoints R and S. Okay, let's just do that first. I was like kind of getting that one done. -1, 1, 2, 3 is right here. That's my R, and then S is 1, 2, 1, 2, 3, 4, 5, 6. Okay, not bad. A little segment there. R and S. Great. Okay, what are we supposed to do with this now? It does just say graph the image, which ultimately means the final piece. I usually graph both. I don't think it's a big deal, especially with the segment here, after the composition. All right, so what's the first thing that has to happen? We have to do a reflection in the y-axis of this. There's a couple different ways to do that. Because we're going over the y-axis, which is right here, we could count, right, and just flip these points over the y-axis. I'm actually going to go back to my notes and check my rule. Okay, so if I look at the y-axis rule, it says this. It says take the point AB and turn it into the point opposite of AB. Okay, so I'm going to use it the rule method, but like I said, there's a couple different ways you could do this one. The reason I like using the rule is because it just fires out the coordinates to me right here in the table, or right here in the box. Okay, so again, that's coming from my notes. That's where that rule came from the previous lesson on reflections. The interpretation is just switch the sign on the first number on your x coordinate. So this becomes 1, this becomes -2, and then leave your y coordinates alone. So that should be 3, and that should stay 6. Okay, so no matter what, this gets done in the box. You should have that second round of that second round of ordered pairs showing up in the box with prime notation. It's up to you to decide. Do I need to put this on the graph, that particular one, or not? I'm going to throw it on there because I don't think it's a big deal. So here's R, that's 1, 3, that's R prime. And then S is -2, 1, 2, 3, 4, 5, 6, which is up here. That's S prime. Okay, I kind of like it just because it's a reflection. It shows up nice there with the colors and everything. Okay, so here's the part. I just want to make sure it's super clear. We have one more round to do. We haven't done this rotation yet. Okay, so now I'm going to show in another set of arrows. We've never done this yet. I got another set of arrows saying, hey, there's another transformation taking place. Okay, what's that transformation? That's going to give us 2 new points, R double prime, which we talked about a little bit in the first lesson on how to use that notation, and S double prime. Okay. All right. So now again, I'm going to go back in my notes. I have them here in front of me, and I'm going to look and see where's my rule for doing a rotation 90 degrees about the origin. I check my notes. It says take the point AB and turn it into the point opposite of B, A. Okay, I feel like, I don't know if we did this one earlier or not. So let's do that. I'm working off of these points right here. I'm done with the original. All right, so what does this say? It says take the X coordinates, which are right here and here, and kick them to the back. So I'm going to kick this 1 to the back, and I'm going to kick this -2 to the back. Those are my new Y coordinates. I didn't mess with the signs. And then this says take the original Y coordinates, bring them up front, and switch the sign on them. So now I'm bringing this 3 from the back. I'm sliding it up front and turning it into -3. And I'm taking this 6, I'm kicking it from the back up to the front, and I'm going to switch the sign on it to -6. Okay? It's nice. You know, there's not really any calculator use or anything like that. It's just obviously being able to have access to those rules and, understanding how to apply them. Last part here is, I think we're done, is just putting it on the graph. So where does that look like after that rotation? We end up at -3, +1. That's my new R double prime. And then -6, 1, 2, 3, 4, 5, 6, -2, which is down here. So I'm going to label those as R double prime, S double prime. Give it the old connect the dot treatment, and we're good. Okay, so nothing too crazy, I don't think there. Just with the compositions, it's just kind of doing 2 in a row. But either way, you're documenting everything the same. You got your double prime notation and graphing both the image and the original pre-image. Not too bad, hopefully. We definitely went through all the rotation stuff. We hit the composition. That was kind of a bonus goal here that we were able to accomplish. But that's it. That's all I got for you. We can check us off. I like doing that. Oh, no, I was going to check us off and say done. Now we're done. That's all I got. I will see you in future lessons.